Let's talk about finding intercepts of non-polynomials. First of all, let me remind you what a polynomial is. So a polynomial looks like this. You can see that the exponents are positive. We don't have any division. Here are some examples of non-polynomials. So you can see here that there's a negative exponent, and you can also see here that we have division. So those are two cases of things that are not polynomials. And that's what we'll be dealing with in today's video. All right, so if I asked you to find the x and y-intercepts of this problem, what would you do? Let's take a second to read this reminder. It says, remember, you find an x-intercept by setting y, which is f of x, equal to 0. And we know that f of x will only be equal to 0 if the numerator is equal to 0. So here's the key. To find x-intercepts, in this case, we just set the numerator equal to 0. Okay, so let me write this as a reminder. X-intercepts are when our y, or our f of x, is equal to 0. Meaning we're trying to get this whole fraction to be equal to 0. And we know that fractions are equal to 0 when the numerator is a 0. So when will our numerator be 0? Well, that will be when x is equal to -8 and when x is equal to -3. See how I said -8 and then -3. And if you don't believe me, you should go ahead and try it. So for example, if I plug in -8, I would get a 0 times a -5 over a -4. And the reason why I do emphasize checking is because we have to make sure that these intercepts are in our domain. We don't want to have an issue in the denominator with any of these two numbers. And if we want to check -3, we certainly can. Plugging in -3 here, we get a 5 times a 0 divided by 1, because -3 plus 4 is 1. And that does give me 0 over 1 is the 0 that we wanted. So those are my two x-intercepts right there. So I can write those as -8, 0 and -3, 0. For my y-intercepts, we always knew from the very start that we get y-intercepts when our x is equal to 0. So all I have to do is plug 0 in for x. So I get 0 plus 8, 0 plus 3, 0 plus 4, which is going to give me an 8 times 3 over 4, which is 24 over 4, which is equal to 6. So my y is equal to 6 when my x is 0, meaning my coordinate is 0, 6. So I have both my x-intercepts and my y-intercepts now. All right, here's the graph of what this looks like, and you can see that we have our 6 was our y-intercept, and our -8 and our -3 are in fact our x-intercepts. Let's try another problem. So as a reminder, for x-intercepts, we set our y equal to 0, which is setting this whole thing equal to 0. And the only time a fraction is equal to 0 is when our numerator is equal to 0. We're going to have to factor this. So I put an a here and an m here. What adds to 4 multiplies to 4. Well, that would be a 2 and a 2. So we'll have an x plus 2 times an x plus 2 all over x plus 1. So when would our numerator be equal to 0? Well, it looks like only when x is equal to -2. And so our x-intercept would be -2, 0, and we are done. Again, like I said, it's always a good idea to check that we have -2 allowed in our denominator, and that's no problem at all. All right, last thing that we have to do here is we are going to find the y-intercept and then talk about the multiplicity of the x-intercepts. So my y-intercept is going to be where I set my x value equal to 0. So that's going to be a 0 squared plus a 4 times 0 times a 4. So this is going to be 4 over 1 equals 4. So this is going to give me the coordinate 0, 4 for my y-intercept. All right, folks, last thing that we need to do is figure out what our multiplicity is of our x-intercept. And just as a reminder, we found that the numerator was x plus 2 quantity squared over x plus 1. So because of this 2, we do have a multiplicity of 2, which means it is going to bounce at that spot. Oopsie. All right, going ahead and looking at this, we can see that that is true at -2. It's a little bit unclear here. You can see that we do in fact have a bounce at the -2 that we identified. And yes, our y-intercept is the 4 that we found right here. Sweet. I think we'll just do one more and we'll call this good. So find the x and y-intercepts and then state the multiplicity. So let's go ahead and attack our x-intercepts. So that's when I'm setting this equal to 0. I'm going to factor out an x, and that gives me an x squared plus 5x plus 6 equals 0. And that's going to be an x times an x, let's see, a 3 and 2, right? Because I'm trying to add to 5 and multiply to 6, so that's 3 and 2. Okay, and I could write the denominator if I wanted to, but what I really care about is when my numerator is equal to 0. So where in here do I get a 0 for my numerator? Well, that would be x equals 0, and that's going to be a multiplicity of 1. I've got x equals -3 from the middle, and that's going to be a multiplicity of 1. And then I've got x equals -2, again a multiplicity of 1. And if I want, I could write these as the coordinates 0, 0, -3, 0, and -2, 0. All right, last is going to be our y-intercept, and that's the fun one, the quick one where I just let x equal to 0. All right, so plugging in, I'm going to have a 0 cubed plus a 5 times 0 squared plus a 6 times 0. And I really should put my parentheses, but that's going to give me a 0 divided by 0 plus 4 is 4 equals 0. So that's the point 0, 0. Now looking at our graph, our answer makes total sense because we all had multiplicities of 1, which is why it's just going straight through. It's crossing the graph instead of bouncing. And then do note that our y-intercept was correct. All right, that's it, folks. Thanks for watching.